Hello guys, good to see you back. Once again, I am back with a new project related Python OpenCV. And today in this project, we are going to build the webcam filter switch with the hand gesture. This project is fun, interactive and great way to practice real-time gesture control with OpenCV and MediaPipe using Python. Now, let me show you the demonstration what actually we are going to build today in this project. So as you can see, it start my webcam. For now, my current filter status is original. And if I raise my hand and try to show one finger, still it return current filter is original. But if I raise two finger, now it start applying the filter. For now, it apply gray filter. At the same way, if I raise my third finger, then it going to apply blur filter. You can notice the blur footage at that window. And if I raise my fourth finger, then it's going to apply sepia filter. And if I raise all the finger, I want to say all the 5 fingers, now you can see the edges. Now it apply the edge filter. So this is how we can change different filter using my gesture. We can control filters with my finger. And if you want to close the program, then you need to press escape key in your keyboard. And it's going to exit the program. Basically in this project we are going to create total 3 separate Python files. First we are going to create filters.py. Here we are going to create the filters such as blur filter, edges filter, sepia filter, gray filter, etc. Then we are going to create the gesture control where we are going to build which gesture going to trigger which filter. At the end we are going to create the Python file that we are going to run in this program. So without wasting your time, let's start the practical. Before we start our coding, let me introduce you something. This project is part of my Mastering Python OpenCV course on Udemy, and as you can see, it is the new, fresh and bestseller course on Udemy. Till today, it comes with 11.5 hour plus content on it, and it comes with multiple real-world projects. So if you are interested to learn Python OpenCV from the very beginning, I will provide the link in my description. Just check this course on Udemy and you will understand why it has become bestseller. So let's back to the code. So finally we are in my Visual Studio Code editor. And as I told you, at first we need to create the filters. So I'm going to create a Python file named filters. Filters.py. So at first I'm going to import the module. I'm going to import cv2. Import cv2. It is the OpenCV module for Python. Then I'm going to import NumPy module. So I'm going to type import NumPy as np. After that, I'm going to define a function for the filters. So I'm going to type def and our function name is apply underscore filter. Apply filter inside the round braces. Here I'm going to pass total 2 parameters. First one is frame, and the second one is filter name. Filter underscore name. Then inside this function, here I'm going to set if condition. So type if filter name equal to inside the double quotes gray, then inside this if condition here, I am going to return cv2 dot cvdcol. Inside the round braces here, I'm going to pass the frame. Then I'm going to convert the frame into BGR to gray frame. So type cv2 dot color underscore BGR to gray. That's it. At the same way, we need to create another filter. So here I'm going to type else filter name equal to inside the double quotes sepia. Then inside this elif condition, here I'm going to create this sepia filter. So for that I'm going to type a variable name sepia underscore filter. Sepia filter equal to here we need to use a numpy array. So I'm going to type np dot array. Then inside the round braces, inside the square braces, at first we need to pass the new blue value. So inside the square braces, I'm going to pass 0.272, 0.534, 0.131. Our first value is for red, and the second value is for green, and the third value is for blue, and combine it create new blue value. After comma, inside the square braces, again we need to pass new green value. For that I am going to use these values 0.349, 0.686, 0.168. It is for new green value. Then we need to pass value for new red. So after comma, inside the square braces, here I am to pass the new red value. Basically, here we create a 3x3 transformation matrix using NumPy. It is commonly used for sepia tone. And this matrix is applied to each pixel's values. And this matrix is applied to each pixel's BGR values to produce a sepia effect. Basically, I want to say it's going to perform matrix manipulation for each pixel. And as a result, it's going to return a sepia toned output. And to return the output, here we need to type return cv2.transform. Then inside the round braces, first we need to pass the frame, then we need to apply the filter. So here I want to pass sepia filter, this filter, and I'm going to set this file. And then I'm going to create another filter. And so I'm going to type elif filter name equal to inside the round braces, inside the double quotes, here I'm going to create blur filter. Then inside the elif condition, I want to return cv2 dot Gaussian blur. Inside the round braces, first I'm going to provide the frame name, then after pass the source, inside the round braces we need to pass the kernel size, which is 15, 15. After that, comma, sigma x value 0. Here we create the blur filter. After create the blur filter, I am going to create other filter which is going to display the edges. So I duplicate this section, and here I will type elif filter name equal to edge, otherwise edges. Then inside the elif condition, I want to return cv2 dot. Here I am going to apply Kenny edge detector, some type Kenny. Then inside the round braces, first I'm going to provide the frame, the image frame. Then we need to pass the threshold values. Lower threshold value, first we need to pass the lower threshold value, then we need to pass the upper threshold value. For lower threshold value, I'm going to pass 100, and for the upper threshold value, I'm going to pass 200. And I'm going to set this 5. Basically, in our project, we are going to apply total 4 filter: gray, sepia, blur, and edge. If I show one finger, then it's going to return the original image. And if I show 2 finger, then it's going to apply the gray filter. And if I show 3 finger, then it's going to apply the sepia filter. And if I show 4, then it's going to apply the blur filter. And if I show my 5 finger from my hand, then it's going to apply the edge filter. And it's going to return the edges in our frame. Now after create all the filters, we need to return, because here we create a function. So this function going to return, and it's going to return the frame, actual frame. And I'm going to set this file. So this is it for this tutorial. At the next tutorial, we are going to work on gesture control, and it is the most important part of this tutorial. So thanks for watching this video. Stay tuned for the next part of this tutorial. Hello guys, good to see you back. This is the second part of this tutorial, and at this part we are going to create the gesture control. So for that I am going to create another Python file, and our Python file name is gesturecontrol.py. And at first I am going to import CV2 and MediaPipe module. Some type import I'm going to type CV2. Then I am going to import MediaPipe as MP. Now before we start our journey, let me show you what we need to do in this file. This is how MediaPipe read our hands. It assigns landmark ID to our hand joints, something like that. And if you notice, you can see ID4 represent thumb finger tip and ID8 represent index finger tip and ID12 represent middle finger tip and ID16 represent ring finger tip and ID20 represent pinky finger tip. So we need to target those finger IDs and we need to count these fingers are up or not. Basically we need to create a counter that how many fingers are raised. So let's back to the Visual Studio Code and start the journey. At first we need to initialize the MediaPipe hand module. For that I'm going to type mp underscore hands. mp hands equal to mp dot solutions dot hand. Basically it is the access for hand detection module. After that we need to set a limit. I want to say limited and detecting hand. Hands equal to mp underscore hands dot hands method. Then inside the round braces, here I am going to set a limit, maximum number of hands. So to type max underscore number underscore hands, maximum number of hand equal to, and I'm going to set 1. So it's going to detect only one hand. Here we initialize the hand detection pipeline limited to detecting one hand. After that we need to define the drawing utility. For that I'm going to type mp underscore draw equal to mp dot solution dot drawing utils underscore utils. Basically this line provides the function to draw landmarks and connection on the image. It is used for visual feedback. And now we need to define a function, and our function name is def detect underscore gesture, and as an argument it takes the frame. Then inside this function first we need to convert the frame BGR to RGB. So I'm going to define a variable RGB underscore frame. RGB frame equal to CV2 dot CVD color. Then inside the round braces, here I'm going to pass the frame name, frame, comma, then I'm going to type CV2 dot color BGR to RGB. So here we convert our frame into BGR to RGB color. Next we need to pass the RGB frame to the MediaPipe model that going to detect the hand. For that I'm going to define another variable called result. Result equal to hands dot process. Hand dot process inside the round braces I'm going to pass the RGB frame, and I'm going to set this file. Next I'm going to set a if condition. If hand is detected, so I'm going to type if result dot multi underscore hand underscore landmarks. Then inside the if condition, if result dot multi-hand landmarks, then inside the if condition I'm going to run a loop. This if condition means if one hand is detected, then inside the if condition I'm going to run a for loop. So I'm going to type for hand landmarks hand underscore landmarks in results dot multi-hand landmarks multi underscore hand underscore landmarks then inside this for loop, now inside the for loop we need to convert normalized landmark to pixel coordinates. So here I'm going to create an empty list, landmark underscore list, and it's an empty list. After that, I'm going to run another for loop. For id, landmark id, and landmark lm, landmark in enumerate. Here I'm going to run enumerate function. Inside the round braces I'm going to type hand landmarks dot landmark. Then inside the for loop we need to get the height and width from the current frame. So I'm going to type h represent height, w represent width, and c represent color channel equal to frame dot shape. And next we need to convert the normalized x and y coordinate into pixel position on the screen. For that I'm going to use append method here. Let me show you how. So I'm going to type lm list dot append, and inside the round braces here I'm going to use inside the round braces I'm going to use int function int integer inside the round braces landmark lm dot x coordinate multiply with w. Then again I'm going to use int function int inside the round braces lm landmark dot y coordinate, and also I'm going to multiply it height. First we initialize an empty list to store the x and y position of all landmarks on the hand in pixel format. After that we run a for loop over the 21 landmarks detected on the hand by MediaPipe. Here id represent the index number of the landmark from 0 to 20, and lm represent the landmark object attributes like x-axis, y-axis, and z-axis coordinate. After that we need to get the height and width from these coordinates using frame.shape function, and frame.shape function always return 3 value: height, width, and color channel. How many color channel we use in this frame, and so we need to store 3 value in 3 variable. And at the next line we need to convert the normalized x and y coordinates into actual pixel position on the screen. Suppose our window frame size is 640 by 480, width 640 and height 480, and our landmark x-axis value is 0.5. It's mean 50% from the left, and our landmark y-axis value is 0.25. It's mean 25% from the top. Now we need to multiply with frame width. I mean here I'm going to multiply 0.5 with 640 pixel, and it's going to return 320. At the same way here we are going to multiply 0.25 with 480, and it's going to return 120. So the actual landmark position is 320 by 120. After that I'm going to add this landmark to this empty list using append method. Now it's become very easy to compare the position like which finger is up. Now we can perform gesture logics. Next we need to count the fingers up. So outside the for loop I'm going to type a variable fingers underscore up. Fingers up equal to, here I'm going to initialize with 0. Basically it is a counter for how many fingers are raised. Next we need to define the fingerprint tip ID. So here I'm going to type tip. So here I'm going to type tip underscore IDs. Tip ID is equal to, inside the round brace, inside the square braces I'm going to pass the IDs. ID 4, ID 4, ID 8, ID 12, ID 16, ID 20. First one is for thumb finger ID, then index fingertip ID, then middle fingertip ID, then ring fingertip ID, and at last we have pinky fingertip ID. I want to say this 4 ID this one, this one, this one, that one, and this one. Now, in my landmark list, we have total 21 landmark from our hand joints. And in our tips ID, we have total 5 fingertips. And now we need to set a if condition that going to recognize that the thumb finger is up or not. So I'm going to type if from ML list, I want to set the landmark list inside the square braces. Here we need to identify the 0 index. Here we need to target the thumb fingertip, this one. So I'm going to type tips IDs inside the square braces. I'm going to pass 0 because in this list its index number is 0. So here we target this thumb tip. After target the thumb tip, I'm going to extract it x-axis. And as you know, we save x-axis and y-axis in this empty list. So here I'm going to target the x-axis, and it set the x-axis as 0 index of landmark list. Now, if this condition greater than, if this x-axis value is higher than landmark number 3, I want to say if it is higher than landmark number 3, then it means the finger is up. Let me show you. So let's back to the Visual Studio Code, and here I'm going to target the landmark number 3. To target the landmark number 3, I'm going to copy this same code and I'm going to paste it here. After that, here I'm going to minus 1 value. From the 0 index, I want to minus 1 value. Now the question is why I minus 1 value? Because as you can see here we target the index number 4. Now we need to target the index number 3. So if I minus 1 from the index number 4, it's become landmark number 3. And also we extract the x-axis coordinates of landmark number 3. So if it is greater than 3, then inside this if condition, our finger is up. So I'm going to type finger up, fingers up, and I'm going to increment it plus equal to 1. And I'm going to increment it with 1 way. It means the thumb is extended outward. We increment the finger count. Now the question is why we do the if condition only for the thumb? Because for fingers index to pinky, we compare vertical y-axis position to determine if a finger is up or not. But for the thumb, it is usually sticks out sideways. So we compare horizontal x-axis position. And now I'm going to run a for loop to check the other finger is up or not. So here I'm going to use for loop to check one after another. So I'm type for I in range. Then inside the round braces, and here I'm going to set a range between 1 and 5. Then inside the for loop, here I'm going to set a if condition. If landmark list, from the landmark list, I want to access tip IDs, and this time I'm going to pass I with, and after that I want to access the y-axis, so this time I'm going to not pass 0 index, I'm going to pass 1 index. If it is greater than the previous ID, I want to say, I'm to copy this line and here I'm going to pass the other joint value, other joint y-axis. To extract the other joint from here, I'm going to minus 2. Then inside this if condition, I'm going to type fingers up plus equal to increment with 1, and I'm going to set this 5. Basically here we compare with the middle joint. I want to say this joint, ID number 6, this middle joint. Here we compare with the fingertip with this middle joint 6, 10, 14 and 18. If it is greater than that, it means the finger is up. And then I want to return how many fingers are up. So here, outside the for loop, I want to return, and here I'm going to use f string. Then inside the double quotes, I'm going to type inside the curly braces, fingers up. I'm going to pass this variable. I'm here going to pass this variable. If our any finger is up, then it's going to increment the value. Suppose if our 3 finger is up, then it's going to return 3 value. And I'm going to type underscore fingers. And I'm going to save this file. Basically, it's going to return a string like 2 fingers, 3 fingers, 4 fingers, 5 fingers, etc. It's going to indicate how many fingers are up. Next, we need to return none if no hand is found. So outside the main if condition, I want to return none, because if there is no hand found, we need to return none. That's it. So here we create this separate file for gesture control. At the next part of this tutorial, we are going to create the main file that's going to open our webcam and execute our functions. So thanks for watching this video. Stay tuned for the next part of this tutorial. Hey guys, good to see you back. This is the last part of this tutorial. In our previous tutorials, we create filter.py file and gesturecontrol.py file. In our filter file, we define the filters such as gray, sepia, blur, and edges. And in our gesture control, we create our gestures. Our program going to count how many fingers are up, and according to the finger count, it's going to select the filter. Now we need to create the main file. So here I'm going to type main.py. Now at first I'm going to import CV2 module. Import CV2. After import the module, I'm going to import 2 other modules such as filter.py and gesturecontrol.py. From filter.py file, I want to import this function, apply filter, and from gesturecontrol.py, I'm going to import this function, detect gesture. So here I'm going to type from filters, I want to import apply filter function, apply filter. At the same way, from gesture control, I want to import detect gesture function, detect gesture. After that, I'm going to capture the video frame. For that, I'm going to define a variable cap, and you know the process, equal to cv2 dot video capture method, video capture, and I'm going to open my default webcam, so I'm going to pass 0 here. After that, I'm going to run a while true, while the condition is true, then I'm going to read the capture file, cap.read method, and as you know, it's returned the frame and the boolean value. So for the boolean value, I'm going to define ret variable, and for the frame, I'm going to define frame equal to cap.read method. After that, I'm going to set a condition. If not, there is no boolean value ret, then I want to break the loop. Break. So if there is no boolean value, then it's going to break the loop. After that, I'm going to set another condition, another if condition. So here I'm going to type if cv2 dot wait key, if cv2 dot wait key, inside the round braces I'm going to wait for 1 millisecond, and 0x ff equal to 27, then inside the if condition I want to break the loop. Break. Also we need to release the capture, so I'm going to type cap.release. Also we need to destroy all the windows, cv2 destroy all windows, and I want to set this file. Now after capture the video, here I'm going to define a variable, and our variable name is current filter. Current underscore filter. Current filter equal to, inside the double quotes I'm going to type current filter original. So this is the current filter status. If it is original, then it's going to show the actual frame. It's not going to apply any effect. Now inside this while loop, here I'm going to set a if condition. But before I set the if condition, I want to use this method, detect gesture. So here I'm going to type a variable name called gesture. Gesture equal to, and here I'm going to call this method from the gesture control file, detect gesture, and inside the round braces I'm going to pass the frame we get from this cap variable. And now I'm going to use the if condition. Here I'm going to set if gesture equal to, inside the double quotes I'm going to type one underscore fingers. Then inside this if condition, here I'm going to set current filter equal to, I'm going to make it original. I'm going to use the same width, original. Now the question is, why I compare with one fingers? Why I use one underscore fingers? Because in our gesture control.py file, it return the result. If we raise 2 finger, then it's going to return 2 underscore finger. If we raise 3 finger, it's going to replace 2 with 3 and return how many fingers are raised. That's why here I use compare with one underscore finger. Then I duplicate this section. After duplicate this section, I am going to compare with 2 fingers. If 2 finger is raised, then I want to apply gray. So I'm going to replace original with gray. At the same way, if I duplicate this section and if we raise 3 finger, then I am going to apply blur. At the same way, I am going to duplicate this section. If I raise 4 finger, then I am going to apply sepia filter. Sepia. Then if I duplicate this section and if I raise 5 finger, then I want to apply edge filter. So I'm going to replace sepia with edges. Now according to the result, we need to apply the current filter in this frame. For that, here I'm going to type filtered, a variable name called filtered equal to apply filter. Filter equal to apply underscore filter. Inside the round braces, here I'm first going to pass the actual frame. So I'm going to pass the frame, then I'm going to pass the current filter, which filter I want to apply to this frame. And our filter name is, and our variable name is current filter, this one. Next, we need to ensure the filter output is in 3 color channel format, because we need to display the text over the filter. And if we do not ensure it, it's going to apply it in our text also. It's going to apply all the filters in our text also. For that, here I'm going to set a if condition. If len, I'm going to use len function inside the round braces. Here filtered dot shape equal to 2. Then inside the if condition, here I'm going to change the color. I'm going to make it gray to BGR. So I'm going to type filtered equal to, the filtered frame equal to cv2.cvt color. CVT color. Then inside the round braces, first I'm going to pass the filter. First I'm going to pass the filter frame as a source, filtered, comma, and I'm going to convert cv2 dot color, and I'm going to convert it, I'm going to make it gray to BGR, this one. and I'm going to save this file. After that, I'm going to show the filter name on the screen. For that, I'm going to use putText method. So I'm going to type cv2.putText. PutText inside the round braces. First, we need to pass the image, in which image I'm going to put the text which is filtered. Then I'm going to pass the text. For that I'm going to use f string. Then inside the double quotes, I'm going to pass the current filter name. So type current filter inside the curly braces. Here I'm going to pass the current filter variable, current filter. After that we need to define the origin position of the text, and I'm going to pass from x-axis I'm going to pass 10, from y-axis I'm going to pass 30. Then I'm going to define the font face, and here I'm going to use cv2.fontHache simplex. Let's turn on the word wrap for clear view. After that, we need to define the font scale, and I'm going to make it 1. Then we need to define the color of this font. Inside the double quotes, I'm going to pass, for blue I'm going to pass 0, for green I'm going to pass 255, for red I'm going to pass 0. Then after comma, we need to define the thickness of this font, so I'm going to pass 2 here. After that, I'm going to save this file. Next, we need to show the frame on a window. For that, I'm going to use IamShow method, cv2.IamShow. Then inside the round braces, inside the double quotes, here I'm going to type gesture control filter. After comma, this is the window name. Then after comma, here we need to provide the frame, which is filtered. And I'm going to save this file. And then I use wait key method to exit the window. If we press escape key, it is the SI code of escape key 27, then it's going to break the loop. And I'm going to save this file. After save this file, now I'm going to test our code. But before I run this code, let me explain what we basically done here. At first, we import the required modules such as cv2, then we import the particular functions such as apply filter and detect gesture from the other files. After that, we initialize the webcam, also set a default filter original. Then we start a main loop using while. It is an infinite loop. It continuously reads the webcam frames. After that, using if condition, we detect the gesture and update the filter. And next we apply the current filter to this frame. And our frame name is filtered. And next we ensure that the filter output is in 3 color channel format, so it can display it correctly and text can be overlaid. Next we display filter name on the screen, and at last we show the frame. Now let's run the code in our terminal. So I'm going to hit the run button. After hit the run button, we need to wait for some time to start the webcam. So I'm going to waiting for some time to start the webcam. So as you can see, it start my webcam. For now, my current filter status is original. And if I raise my hand and try to show one finger, still it return current filter is original. But if I raise 2 fingers, now it start applying the filter. For now it apply gray filter. At the same way, if I raise my 3rd finger, then it's going to apply blur filter. You can notice the blur footage at that window. And if I raise my 4th finger, then it's going to apply sepia filter. And if I raise all the finger, I want to say all the 5 fingers, now you can see the edges. Now it apply the edge filter. So this is how we can change different filter using my gesture. We can control filters with my finger. And if you want to close the program, then you need to press escape key in your keyboard. And it's going to exit the program. So this is what we built today in this project. I hope you enjoy this project. Thanks for watching this video. Stay tuned for the next project.